Today we are going to see how to solve indeterminate forms using expansions of functions. So far we have seen how to solve indeterminate forms first by converting them into 0 upon 0 or infinity upon infinity indeterminate forms by suitable algebraic manipulations and then solving them by L'Hopital's rule. In present video, we are going to see how to solve indeterminate forms by using expansion of functions, which in many cases simplifies the solution. Let us see how. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. You can even check playlist of this channel. Perhaps you might find videos that you are looking for. In the first example, we will use expansion of cos x to solve this limit as x tends to 0 to cos x minus 2 minus x square upon x raised to 4. We will solve the numerator first. 2 into expansion of cos x 1 plus x square upon 2 factorial plus x raised to 4 upon 4 factorial plus so on and so forth, minus 2 minus x square, opening the bracket, 2 plus 2x square upon 2 plus 2x raised to 4 upon 4 into 3 into 2 plus so on and so forth, minus 2 minus x square. Cancelling this 2 and this 2, 2 minus 2 will be 0 and x square minus x square will also be 0. So we get x raised to 4 upon 12 plus 2x raised to 6 upon 6 factorial plus so on and so forth. So this limit becomes limit as x tends to 0. In the numerator we have 1 upon 12 x raised to 4 upon this denominator x raised to 4 plus 2 upon 6 factorial x raised to 6 upon this x raised to 4 plus so on and so forth. Cancelling this x raised to 4, limit x tends to 0, 1 upon 12 plus terms containing powers of x. So this limit finally reduces to this 1 upon 12. So value of limit will be 1 upon 12. Evaluate limit as x tends to 0. Sin inverse x minus x upon x cube. Limit x tends to 0. Expansion of sin inverse x is given here. X plus x cube upon 6 plus 3x raised to 5 upon 40 plus so on and so forth minus x upon x cube. X minus x is 0. This will be limit as x tends to 0. 1 upon 6 plus 3 upon 40 x square plus so on and so forth. Limit as x tends to 0. 1 upon 6 plus terms with higher powers of x. So this limit will be 1 upon 6. Evaluate limit as x tends to 0 of 2 raised to x minus 1 upon 1 plus x raised to half minus 1. Limit as x tends to 0. We will write expansion of 2 raised to x from the expansion of a raised to x. That will be 1 plus x log 2 plus x square upon 2 factorial log 2 square plus x cube upon 3 factorial log 2 cube plus so on and so forth minus this 1 upon expansion of 1 plus x to the power 1 upon 2 from this expansion. It will be 1 plus half x upon 1 factorial plus half into half minus 1 x square upon 2 factorial plus so on and so forth minus this 1 minus 1 0. This 1 minus 1 is also 0. So the limit reduces to x log 2 plus x square upon 2 log 2 whole square plus so on and so forth upon half x minus 1 upon 8 x square plus so on and so forth. This will be limit as x tends to 0. Taking x common in the numerator, log 2 plus x upon 2 log 2 whole square plus so on and so forth upon taking x common in the denominator, x into half minus 1 upon 8x plus so on and so forth. After cancelling this x, this limit further will be limit as x tends to 0. This log 2 plus terms with x upon this half plus terms with x. So this limit finally will be log 2 upon half 2 log 2. Evaluate limit as x tends to 0. E raised to x sin x minus x square upon x square plus x log 1 minus x. Limit as x tends to 0. We write expansion of e raised to x from here into expansion of sin x from here minus x square upon x square plus x into expansion of log 1 minus x from here. Limit as x tends to 0. 1 into x 1 into minus x cube upon 3 factorial minus x cube upon 3 factorial x into x plus x square upon 2 factorial into x plus x cube upon 2 factorial plus so on and so forth minus this x square upon x square x into minus x square minus x cube upon 2 minus x raised to 4 upon 3 minus so on and so forth x minus x 0 x square minus x square 0 x square minus x square 0. Limit as x tends to 0. We will take x cube as common factor in the numerator. So x cube into minus 1 upon 6 plus 1 upon 2 plus terms with x upon we will take x cube common in the denominator. So x cube into minus half minus x upon 3 plus terms containing x up to infinity. Cancelling x cube, this will be limit as x tends to 0. Half minus 1 upon 6 is 1 upon 3 upon minus half. This will be minus 2 upon 3. So this is the value of the limit minus 2 upon 3. Evaluate limit as x tends to 0. E raised to x minus e raised to minus x plus 2 sin x minus 4x upon x raised to 5. Limit as x tends to 0. We write expansion of e raised to x from here minus expansion of e raised to minus x from here plus 2 times. We write expansion of sin x from here minus 4x upon x raised to 5. Limit as x tends to 0. 1 minus 1 is 0. X plus x 2x 2x plus 2x 4x minus 4x 0. X square upon 2 factorial minus x square upon 2 factorial is 0. X cube upon 3 factorial plus x cube upon 3 factorial which is 2x cube upon 3 factorial minus 2x cube upon 3 factorial will be 0. X raised to 4 upon 4 factorial minus x raised to 4 upon 4 factorial will be 0. X raised to 5 upon 5 factorial plus x raised to 5 upon 5 factorial 2x raised to 5 upon 5 factorial plus 2 times x raised to 5 upon 5 factorial, that will be 4 x raised to 5 upon 5 factorial plus so on and so forth upon this x raised to 5 which is limit as x tends to 0. Cancelling x raised to 5 we get 4 upon 5 factorial which is 4 upon 5 into 4 into 3 into 2. Cancelling 4 we get 1 upon 30 which is the value of the limit. Evaluate limit as x tends to 0. E raised to x minus e raised to x cos x upon x minus sin x. First, we will simplify e raised to x cos x separately. E raised to x cos x will be, according to this expansion of e raised to x, 1 plus x cos x plus x square cos square x upon 2 factorial plus x cube cos cube x upon 3 factorial plus so on and so forth up to infinity, which is 1 plus x into expansion of cos x 1 minus x square upon 2 factorial plus x raised to 4 upon 4 factorial minus so on and so forth plus x square into expansion of cos x 1 minus x square upon 2 factorial plus so on and so forth whole square plus upon 2 factorial plus x cube into expansion of cos x 1 minus x square upon 2 factorial plus so on and so forth whole cube upon 3 factorial plus so on and so forth. That will be 1 plus x into 1 x minus x into minus x square upon 2 factorial x cube upon 2 plus x into x raised to 4 upon 4 factorial x raised to 5 upon 4 factorial plus so on and so forth plus this 1 upon 2 factorial x square into this 1 square 1 plus so on and so forth plus this 1 upon 3 factorial, which is 1 upon 6, this x cube into this 1 cube is 1 minus so on and so forth plus so on and so forth. So e raised to x cos x will be 1 plus x plus this x square upon 2 multiplied by 1 x square upon 2 minus this x cube upon 2 plus 1 upon 6 x cube multiplied by 1 x cube upon 6 plus this x raised to 5 upon 4 factorial plus so on and so forth. Now we write numerator, which is e raised to x minus e raised to x cos x, which is expansion of e raised to x from here 1 plus x square upon 2 factorial, which is 2 plus x cube upon 3 factorial, which is 6 plus so on and so forth minus expansion of this e raised to x cos x 1 plus x square upon 2 minus x cube upon 2 plus x cube upon 6 will be minus x cube upon 3 plus so on and so forth. Numerator will be 1 minus 1 0 x minus x 0 x square upon 2 minus x square upon 2 0. This x cube upon 6 minus plus x cube upon 3 plus terms containing x. So that gives numerator x cube upon 2 plus terms containing x. Now the denominator x minus sin x will be x minus expansion of sin x from here x minus x is 0. So denominator will be this x cube upon 3 factorial, which is 6 minus this x raised to 5 upon 5 factorial. So this limit will be limit as x tends to 0 x cube upon 2 plus terms containing higher powers of x upon denominator x cube upon 6 plus terms containing higher powers of x. So that will be cancelling x cube 6 upon 2 3. So this is the value of the limit 3. By now you must have understood, while evaluating indeterminate forms by using expansions of functions, we must remember at least following 3 things. Number 1, to remember correctly the expansion formulae. Secondly, you have to take into consideration terms in the expansion only up to the terms that might get cancelled with the like terms in the denominator, leaving a constant. And thirdly, you must have adequate command over algebraic manipulations of the terms in the expansion. Evaluate limit as x tends to 0 of e raised to x sin x minus hyperbolic cos h x root 2 upon x raised to 4. First we find expansion of e raised to x sin x, which is expansion of e raised to x sin x according to this expansion e raised to x, which is 1 plus x sin x plus 1 upon 2 factorial x square sin square x plus 1 upon 3 factorial x cube sin cube x plus so on and so forth, which is 1 plus x into expansion of sin x from here x minus x cube upon 3 factorial plus so on and so forth plus x square upon 2 factorial expansion of sin x square plus so on and so forth, which is 1 plus x square minus x into minus x cube upon 3 factorial x raised to 4 upon 6 plus so on and so forth plus x square upon 2 into square of x square minus so on and so forth plus so on and so forth, which is 1 plus x square minus x raised to 4 upon 6 plus this product x raised to 4 upon 2 plus so on and so forth. So finally e raised to x sin x will be 1 plus x square, and addition of these two terms gives plus x raised to 4 upon 3 plus so on and so forth. We will name this 1. Next we find expansion of hyperbolic cos x root 2. That will be according to this expansion 1 plus 1 upon 2 factorial x root 2 square plus 1 upon 4 factorial x root 2 raised to 4 plus so on and so forth. That will be 1 plus 2x square upon 2 plus 4 raised to 4 upon 4 into 3 into 2 plus so on and so forth, which is cancelling 2 and cancelling 4. Expansion of hyperbolic cos x root 2 will be 1 plus x square plus x raised to 4 upon 6 plus so on and so forth. We will name this 2. Now from this 1 and 2 we will write this limit as x tends to 0 1 plus x square plus x raised to 4 upon 3 plus so on and so forth, from 1 minus 1 plus x square plus x raised to 4 upon 6 plus so on and so forth, from 2 upon x raised to 4. This is limit as x tends to 0 1 minus 1 0 x square minus x square 0 x raised to 4 upon 3 minus x raised to 4 upon 6 terms containing higher powers of x upon x raised to 4, which is 1 upon 6 x raised to 4 upon x raised to 4 plus terms of x so on and so forth. Cancelling x raised to 4, the value of limit will be 1 upon 6. Evaluate limit as x tends to 0 1 plus x to the power 1 upon x minus e plus half ex upon x square. First we will find expansion of 1 plus x to the power 1 upon x. Let y equals 1 plus x to the power 1 upon x. Now taking logs on both sides, log y equals 1 upon x log 1 plus x according to rules of logarithm. This will be 1 upon x into expansion of log 1 plus x from here, which is 1 minus x upon 2 plus x square upon 3 minus so on and so forth. This we write as log y equals 1, and for this part we will assume z. So according to rules of logarithm we will get y equals this e to the power 1 plus z, that will be e into e raised to z. So y equals e into expansion of e raised to z is 1 plus z square upon 2 factorial plus so on and so forth. That will be e into 1 plus we have z equals minus x upon 2 plus x square upon 3 minus so on and so forth plus 1 upon 2 factorial, that is 1 upon 2 into z minus x upon 2 plus so on and so forth whole square plus so on and so forth. This will be e into 1 minus this x upon 2 plus this x square upon 3 plus so on and so forth plus half into square of minus x upon 2 x square upon 4 plus so on and so forth plus so on and so forth. This will be e into 1 minus x upon 2 plus x square upon 3 plus this x square upon 8 plus so on and so forth. That will be y equals e into 1 minus x upon 2 plus x square upon 3 plus x square upon 8 will be 11 upon 24 x square minus so on and so forth. Now the limit to be solved will be, for 1 plus x raised to 1 upon x, we write this minus this e plus this half ex upon this x square, opening the bracket, e into 1 e minus e into x upon 2 plus 11 upon 24 e into x square minus so on and so forth minus e plus e into x upon 2 upon x square. That will be limit as x tends to 0. E minus e 0 minus ex upon 2 plus ex upon 2 0. We are left with 11 upon 24 ex square minus so on and so forth upon x square. That will be limit as x tends to 0, cancelling x square, 11 upon 24 e plus terms with x, that gives 11 upon 24 e, and this is value of the limit. Evaluate limit as x tends to 0, 2x square minus 2 e raised to x square plus 2 cos x raised to 3 upon 2 plus sin cube x upon x raised to 4. First we will write expansion of this e raised to x square according to expansion of e raised to x, 1 plus x square plus x raised to 4 upon 2 factorial plus so on and so forth. Then we write expansion of cos x raised to 3 upon 2 according to this expansion of cos x, 1 minus x raised to 3 upon 2 raised to 2 will be x cube upon 2 factorial plus so on and so forth. Expansion of sin cube x will be according to this expansion, x minus x cube upon 3 factorial plus so on and so forth whole cube. That will be cube of x cube plus so on and so forth. Substituting all these values in this limit, we get limit as x tends to 0 of this 2x square minus 2 into expansion of e raised to x square from here plus 2 times expansion of cos x raised to 3 upon 2 from here, 1 minus x cube upon 2 plus so on and so forth plus expansion of sin cube x from here plus x cube plus so on and so forth upon this x raised to 4. This is 2x square minus 2 minus 2x square minus x raised to 4 plus so on and so forth plus 2 minus x cube plus x cube upon x raised to 4. Limit as x tends to 0, 2x square minus 2x square 0 minus 2 plus 2 0 minus x cube plus x cube 0 minus x raised to 4 terms in higher powers of x upon x raised to 4, which is limit as x tends to 0, cancelling x raised to 4 minus 1 plus terms containing x, and that will be minus 1. So this is the value of the limit, minus 1. Viewers, if you like this video, please click the like button. Share this video with your friends and classmates. Subscribe to this channel. Post your constructive comments to make the videos better. You can even check playlist of this channel. Perhaps you might find videos that you are looking for. See you in the next video. Until then, keep watching Number Collage. Thank you.